Hi, this is your Professor Sudha Kolathuparambal, Section 9.1 Basic Principles of Hypothesis Testing. In this section, you're going to learn how to define a null and alternate hypothesis, how to conclude hypothesis test, and how to distinguish between type 1 and type 2 errors. Suppose that a new engine is designed to reduce one form of the air pollution that the health officials are most concerned about, that is the particulate matter, which refer to fine particles that can be trapped into lungs, increasing the risk of respiratory disease. Either the new design will reduce the level of PM or it will not. These two possibilities are called the hypothesis. One of the hypotheses is called the null hypothesis, the other one is alternate. The null hypothesis states that the parameter is equal to the specific value mu0. Null hypothesis is denoted by H0. The alternate hypothesis is denoted by H1. And there are three possibilities for the alternate hypothesis. A left-tailed, a right-tailed, and a two-tailed. A left-tailed alternate hypothesis, mu is less than 35. And the right-tailed alternate hypothesis, mu is greater than 35. And two-tailed alternate hypothesis, mu is not equal 35. The educator believes that, so mu not equal. A box of certain kind of cereal are labeled containing 20 ounces. An inspector thinks that the mean weight may be less than this. State the appropriate null and alternate hypothesis. The null hypothesis says that there is no difference. So null hypothesis will be mu equal 20. Since the inspector thinks that the mean weight may be less than 20, so the alternate hypothesis will be mu less than 20. So in general, a null hypothesis says that the parameter is equal to a certain value, while the alternate hypothesis says that the parameter differs from this value. Often the null hypothesis is a statement of no change or no difference, while the alternate hypothesis states that the change or difference has occurred. In example 2, the mean monthly rent for an apartment in a certain city was $800. A real estate agent believes that the mean rent is higher this year. That means more than $800, right? That will be the alternate hypothesis. So null hypothesis says that there is no change. So null hypothesis will be equal 800 and alternate hypothesis will be mu greater than 800. In example 3, the mean of the test score is 70. The educators believes that after making some modification, the mean might have changed. They are not specifically saying whether it is increased or decreasing. They are just saying the mean has changed. That means mu not equal 70. So your null hypothesis will be there is no change. So mu is equal 70. And the alternate hypothesis will be it is changed, so not equal 70. The idea behind a hypothesis test is similar to a criminal trial. At the beginning of the trial, the defendant is assumed to be innocent. Then the evidence is presented. If the evidences strongly indicate the defendant is guilty, we abandon the assumption of innocence and conclude that the defendant is guilty. In a hypothesis test, the null hypothesis is like the defendant in a criminal trial. At the start of a hypothesis test, we assume that the null hypothesis is true. Then we look at the evidence which comes from the data that we have to be collected. If the data strongly indicate that the null hypothesis is false, then we abandon our assumption that it is true and believe the alternate hypothesis instead. This is referred to as rejecting the null hypothesis. Objective 2. State conclusions of hypothesis test. We may either reject the null hypothesis or fail to reject the null hypothesis. If the null hypothesis is rejected, the conclusion is very straightforward. We conclude that the alternate hypothesis is true. If the null hypothesis is not rejected, we are saying that there is not enough evidence to conclude that the alternate hypothesis is true. We are not saying that the null hypothesis is true, but we are saying that the null hypothesis might be true. So let's look at some example. A box of cereal, it is labeled that it contains 20 ounces. An inspector thinks that the mean weight may be less than 20 ounces. So he performed the test and rejects the null hypothesis. So we need to state an appropriate conclusion. Because the null hypothesis is rejected, we conclude that the alternate hypothesis is true. We express the alternate hypothesis in words that we conclude that the mean weight of the cereal box is less than 20 ounces. In the first example, he rejects the null hypothesis. Assume that he does not reject the null hypothesis. Then how do we conclude this? In the second example, this is the same problem, but he does not reject the null hypothesis. The null hypothesis is not rejected, so we do not have sufficient evidence to conclude that the alternate hypothesis is true. We can express this like there is no enough evidence to conclude that the mean weight of the cereal box is less than 20 ounces. Or in another way, we can state that the mean weight of the cereal box may be equal to 20 ounces. Objective 3. Distinguish between type 1 and type 2 errors. When a hypothesis test is conducted and decision is made, there is a possibility that there might be a wrong decision or we made a wrong decision. There are two ways which the wrong decision may occur in hypothesis testing. First one is if the null hypothesis is true and we might mistakenly reject it. And the second is if the null hypothesis is false and we might mistakenly decide not to reject it. The first one is known as the type 1 error and the second type is known as the type 2 error. So rejecting H0 when H0 is true is called the type 1 error. And fail to reject H0 when H0 is false is known as the type 2 error. So let me explain this again. Type 1 and type 2 errors if it is in a trial. In a trial, the null hypothesis is that the defendant is innocent. A type 1 error occurs if an innocent defendant is found guilty. A type 2 error occurs if a guilty defendant is found not guilty. So let's look at this example. The Dean of Business School wants to determine whether the mean starting salary of graduates of their school is greater than 50,000. She will perform a hypothesis test with the following null and alternate hypothesis. Null hypothesis is mu equal 50,000 and alternate hypothesis mu greater than 50,000. Suppose that the true mean is 50,000 and the dean rejects the null hypothesis. Is this a type 1, type 2 or correct decision? So mu equal true mean is 50,000. That means null hypothesis is true, right? Okay. Because the dean rejects the null hypothesis, so you can look at the above null hypothesis is true, but the dean is rejecting. That means that is a type 1 error. But H0 is rejected. Okay. In example 2, assume that the true mean is 55,000 and the dean rejects the null hypothesis. Is this a type 1 error? So mu is 55,000 means it is H0 is false, right? So H0 is false and the dean rejects. Okay, so this is actually a correct decision. So this is a correct decision. Okay, now look at example 3. The true mean is 55,000. The dean does not reject H0. Is this a type 1, type 2 or a correct decision? So the true mean is 55,000 and the null hypothesis is false because the dean does not reject the null hypothesis. So if you look at the above table, null hypothesis is false and fail to reject the null hypothesis. That is a type 2 error. So you can think this is the intersection of these two. So that is a type 2 error. So this is a type 2 error. So in this section, you learn how to write the null and alternate hypothesis, how to determine whether the hypothesis test is left-tailed, right-tailed or two-tailed, and how to state the conclusion to a hypothesis test, and how to distinguish between type 1 and type 2 errors and correct decisions.